Hello, 7th graders. This is Miss White, and today we're doing the Module 5 study guide. We're going to go ahead and start with number 1. First, we need to understand that we need to round all decimal answers to the nearest hundredth, and we will talk more about that in our answers. So number 1, for each student in a class of 33 students, was asked to report how many activities they participated in. The data are summarized in the table below. Here is our data. And for A, it says, based on the data, estimate the probability that a randomly selected student from the class participates in no activities. So if we're talking about no activities, then that means that we need to look at the amount that participate in 0 activities. Now, we see for our 0 activities here, the amount of students was 5. So how we're going to write that as a probability is we're going to have 5 over 33. So now that we have 5 over 33, go ahead and take out a calculator, and I would like you to do 5 divided by 33 to get this in decimal form. All right, and the answer that you should have got is 151 thousandths. Now, I know that this is actually a longer decimal, but we're just going to stop at the thousandths, and here is why. The thousandths place is going to help us to know whether or not we need to round up to our hundredths place, which is the 5. So is 1 going to round our 5 up to 6? Well, is 1 5 or greater? No. So it is going to stay the same, and we are going to have 15 hundredths as our answer. All right, let's go on to B. Based on the data, estimate the probability that a randomly selected student from this class participates in 2 or more activities. So this time we're going to look at 2, 3, 4, 5, or 6 because it's asking for 2 or more. So we are going to estimate this based on our count below. Here, we're going to start off with 10 over 33. Then we're going to add 8 over 33. Again, then we're going to add 3 over 33 plus 1 over 33 and then plus 2 over 33. Now, anytime we add a fraction or fractions, we have to make sure that our denominators are the same. Luckily for here, we do have the same denominators, which means we can just add our numerators together. So you can do this in your head or with a calculator, but we are going to add 10 plus 8 plus 3 plus 1 plus 2. All right, and now the answer we get for that is going to be 24. And remember, it's going to be 24 over 33 because our denominator stays the same. Just like above, we are going to estimate this in decimal form, and we want to go to the thousandths first. So let's go ahead. In our calculator, we are going to get a longer decimal number than this, but we went around to the thousandths, and so we got 727 thousandths. Now we want to round to the hundredth. So here is my hundredths place. I'm going to look at the 7, and I'm going to ask myself, does 7 going to round 2 to 3? Well, is 7 5 or greater? Yes, 7 is greater than 5. So we are going to round this up to 73 hundredths. All right, whatever you need to get done right now for this page, go ahead and write it down, and then we will move on to the next. All right, number 2. You and a friend decide to conduct a survey at your school to see whether students are in favor of the new desk and chairs. Your friend stands at the school entrance and asks the opinions of the first 200 students who come to campus on Monday. You obtain a list of all the students at school and randomly select 50 to survey. Now, please remember to use those tools from ELA, the chunking and rereading if you need to during your test. A. Your friend finds 75% of his sample is in favor of the new desk and chairs, but you will only find 50%. Which do you believe is more likely to be representative of your school population? Well, let's think about this. Your friend goes to school Monday morning and he asks the first 200 kids who walk into the school. Well, what about the other kids? What about them? So what's happening is that your friend is only taking a survey of kids who come to school early. Now, you get a list of everyone from the school and you randomly select 50 to survey. Maybe you randomly chose them by putting them into a computer system and having them pick them out for you, or the way that we did it on the random number table, you just closed your eyes and put your finger down on a name. So which scenario seems to be more likely to be the representative of the school population? Well, here's the thing. Your students were randomly chosen instead of only the early arrivals to school like your friend had done. So your students would be more of a representative. So the way to answer this is to say that my students were randomly chosen instead of only the early arrivals. So my students would be more representative. And remember, we're talking about the representative of the school population as a whole. All right, let's go on to B. Suppose 55% of the students at the school are in favor of the new desk and chairs. Below is a dot plot of the portion of students who favor the new desk and chairs for each of the 200 different random samples of 50 students after school. So we can kind of infer that we took our friends' data here, and I'm going to add this dot for some reason. I don't know why it cuts the top dot in half, but it's meant to be a full dot, so let's go ahead and make it a full dot. But we took his 200 samples and we took 50 of those samples out to make our dot plot. So now, if you were to select a random sample of 50 students and ask them if they favor the new desk and chairs, do you think that your sample proportion will be within 5/100ths of the population proportion? Explain. Okay. So as we look at our dots here, we can kind of say, okay, the cluster of our dots, the biggest amount of our dots is going to be about 5/10 to 7/10. And I know here on this, I couldn't get them to label all of them, so we can go ahead and label them here. So we're going to have 0.5 here and 0.7. If you want to label the rest, you can. Okay. So we kind of see here that our cluster is going to be between 0.5 and 0.7. Now, if we count all these dots, I believe here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so we have 11 dots here. That means we have 12 dots here. And then how many dots do we have for 7? 1, 2, 3, 4, 5, 6, 7, 8. Okay. So if we add all these up, 11 plus 12, which is going to give us 23, plus 8, which is going to give us 31. That means 31 out of 50 of our samples are going to be between 5/10 and 7/10. Okay, so there is more than half of these samples are between 5/10 and 7/10. So there is a good chance that 55% of these students would favor the new desk and chairs, and that's what we could use to support that. How would we write that? Is we would want to say yes. More than half of these 50 samples are between 5/10 and 7/10, so there is a good chance. Now, if we think about it real quick, it's asking it to be within 5/100ths of the population, so it could even be a little less. So you kind of just want to make sure that you're estimating not the exact percentage, but somewhere close to it. All right, when you're done writing all of this down, go on to the next and last page. All right, number 3. A student purchases a bag of salted almonds. After opening the bag, they find one almond that does not have a salted coating. The student then wonders how unlikely it is to randomly find an almond without salt on it for this brand. So for A, it says based on the bag of 20 almonds, estimate the probability of this company producing an almond that is not covered with salt. So we found one almond in our bag that wasn't covered with salt out of the 20 almonds in this bag. So we are going to go ahead and write the probability for this, and that is going to be 1 over 20. Now we'd like to put that into decimal form. Go ahead in your calculator and do 1 divided by 20. All right, and the answer it's going to give for us is 5/100. Now, suppose the almond company claims that 95% of all the almonds it produces contains a salted coating. Explain how you could simulate randomly selecting 20 almonds, one bag, from such a population to determine how many of the sampled almonds do not have a salted coating. Explain the details of your method so it could be carried out by another person. Okay. Ideally on your test, any simulation you come up with that's correct, of course I will give you credit. But I am going to give you an example that you can even use on your test to help us understand how we can simulate randomly selecting 20 almonds from a population. Of course, the question on your test is going to be different than the almonds, but you'll be able to relate it to whatever your question is about on your test. So here's what we're going to do. We are going to use 100 counting chips. Some are going to be red and some are going to be blue. Now, let's go ahead and start to write this down. So again, we have those 100 counting chips. Okay. And they're going to be in a bag because we're going to draw from them. That way they are random. Okay. So now we're going to have some that are red. The red ones are going to represent the almonds that are salted, that have that salted coating. Our company says that 95% of those almonds are salted. So we can go ahead, circle 95%, and we are going to use that to represent the amount of red chips. So we're going to have 95 red chips to represent 95% of the salted almonds. So 95 are red to represent salted almonds. Okay, now we are going to use blue to represent the ones that are unsalted. So if we know out of 100, 95 are red, then 5 are going to be blue. So we're going to have 5 are blue to represent unsalted almonds. Now to record, we are going to pull out a chip, record its color, and then put it back. We're going to do this a certain amount of times and count how many are blue. Okay, so again, we're going to pull out a chip from that bag, record its color, whether it's red or blue, and then put it back. That way we can have the same probability simulation each time. Now we're going to do this, it doesn't matter how many times, but we're going to put down here 20 times and count how many are blue. Go ahead and pause this video if you need more time to write this down. C. Now explain how you could use simulation to estimate the probability of obtaining a bag of 20 almonds with exactly one almond with no salted coating. Well, here's what we would do. We would end up repeating the process from what we answered here in B. And we can do that multiple or more times. I think a good number to really get an estimate of this brand would probably be about 1,000 bags to see what portion of the 1,000 bags had exactly one unsalted almond. The number that we get that are unsalted out of that 1,000 is your estimate of the probability of the bag of 20 almonds with one unsalted almond. So, again, we will want to repeat the process that we came up with above about 1,000 times to get a good indication of how many times how many times we buy a bag of these almonds, are we only going to get one? And again, we want to see that portion of the 1,000 bags had exactly one unsalted almond. Now we would put that number, for instance, let's say out of the 1,000, we had 50 bags that had one unsalted almond out of 1,000. That is how we would write our fraction. Now, again, we put that number, or the number, over 1,000, and this is your estimate of probability of the bag of 20 almonds with one unsalted almond. All right, now this fraction is just an example, okay? We do not need to solve it, but again, we would do this simulation 1,000 times. Let's just say again that we only found 50 bags with one unsalted almond in them. And so that is how we would write that estimate. Of course, we would want to simplify, and of course, we would want to find that decimal form and probably a percentage, but that is not exactly what our question is asking us. It's just asking us how we would simulate. All right, this is the end of the video. Please make sure you have everything written down so you can turn in your study guide for full credit. I will see you guys in class, and congratulate yourself as you are watching your last math video during the COVID year of being a 7th grader.